In this video, we are going to talk about Newton's second laws of motion. So Newton's second laws of motion state that the acceleration and mass, they are inverse proportion to each other. So what it means there is that if we have this, we are saying that we know that force is given by mass times acceleration. So if I want to find the mass or I want to find the acceleration, I can divide both sides by the mass, even here by the mass. So I can say that the acceleration is going to be equal to the force divided by the mass. So as we can see here that the acceleration and the mass, they are inverse proportion to each other. So meaning that the moment when the acceleration goes up, the mass has to go down. The moment when the acceleration goes down, the mass has to go up. So that is the relationship which is there between the mass and the acceleration. Okay, so if you have got an object which has got bigger mass, meaning that the acceleration has to be small. If you have got an object which has got small mass, the acceleration has to be greater. Okay, so now what it means there is that whenever we are talking about Newton's laws of second Newton's laws of motion, we are going to be considered to say the F net is going to be equal to the mass times acceleration. So this is the Newton's second laws of motion. So the acceleration and the mass, they're inverse proportion to each other. Now let's solve this question. This question is saying, as a fish jumps vertically up out of the water, assume that only two significant forces act on it: an upward force F exerted by the tail fin and the downward force due to the gravity. A record Chinook salmon has a length of 1.5 meters and a mass of 61 kgs. If this fish is moving upward at 3.00 meters per second as its head first break the surface and as an upward speed of 6.00 meters per second after two-thirds of its length has left the surface, assume constant acceleration and determine part A, the salmon's acceleration, part B, the magnitude of the force F during this interval. Now it is very important for us first to come up with data. Data is going to help us to know which formula is suitable for us to use. So we have been given the mass of the fish as 61 kgs. We have been given the initial velocity, which is 3 meters per second. We have been given the final velocity as the 6 meters per second. We have been given also the what? The displacement. Now we have been told that the displacement which we have, so we can say the change in x which we have been given is 1.5. But now we have been told that let's first come up with a free body diagram. So if this is the fish, okay, let me draw it here. If this is the fish, so they are saying that the length of this fish is just basically 1.5. So from here all the way to this part is 1.5 meters. Then they want us to find, they are saying that the question is saying that when it was out, the distance which was there, it was two-thirds of the total length. So two-thirds is 2 over 3. So this distance is the distance which was outside, meaning that this two-thirds is this one. So we need to find that distance. So we can say that is the change in x which we want to find. So to find this two-thirds, we need to do times 1.5. Okay, meaning that as long as we find this, meaning that is the distance of the fish, the part of the fish which was outside water. So now what we need to do there is going to be 2 divided by 5. Oh, divided by 5 is two-thirds. So it's supposed to be 2 over 3, not 5. 2 over 3. So it's going to be 2 divided by 3 times 1.5. So I'm getting 1. Meaning that my change in x now, it is 1 meter. That is the distance which was there when the fish was outside what? The water. Okay, now the first question is they want us to find the acceleration. So we have the data. So we have the data now. The change in x now is 1. This is the data which we have. So according to this data, the formula which it can help us to find the acceleration, since we don't have time, it can only be this. So we want to find the acceleration. The final velocity is 6. So we put 6 squared has to be equal to, the initial is 3 squared plus 2. We want to find the acceleration. The displacement is 1. So we can shift this to the other side. We have 6 squared minus 3 squared is going to be equal to 2a, because 2 times 1 is just going to be 2. So we divide both sides by 2, even here by 2. So our acceleration is going to be equal to, we have 6 squared minus 3 squared, everything divided by 2. So I'm getting 13.5 as my acceleration. So this is my acceleration. Now the next question is saying, so let's put our acceleration here. We are saying is 13.5 meters per second squared. The next question is saying, find the magnitude of the force during this interval. What it means there is that since they are saying that the only forces which are acting on this fish is, we only have the upward force, which is the force which we are trying to find, and the weight due to gravity, the downward force, so which is going to be the weight of this object, the weight of this fish. So we can say that according to Newton's second law, the summation of all the forces in or we can say the F net, we are going to have what forces do we have? We have the upward force, which is F, minus the downward force, which is W, the weight force of the fish. So according to Newton's second law, we need to replace this with the mass times acceleration, as long as we have acceleration. But if we don't have acceleration, meaning we replace this with 0. So we have acceleration, we are going to replace this one with mass times acceleration is going to be equal to the force minus this downward force is just basically m times g. So our goal is to find the force. What are we going to do? We are going to shift this to the other side. It's going to be the mass times acceleration plus mg is going to be equal to the force. So let's plug in the values. So we are going to have the mass, which is 61, times the acceleration 13.5, then plus the mass 61 times 9.8. So our force is going to be equal to, so we have 6.13, 6 times 13, oh, it's 61, sorry, 61 times 13.5. So I'm getting 823.5 plus, so we have now 61 times 9.8. I'm getting a 597.8. So we add those two. So our force, the magnitude of the force is going to be 823.5 plus 597.8. So I'm getting a 1421.3. A 1421.3 newtons. So this is our magnitude of the force. So this is how you come up with the acceleration and the magnitude of the force.